Hi, I'm Professor Becca Thompson at St. Edward's University, and my research funded by I4 was investigating essentially spontaneously self-assembling surfaces. So there are a special class of molecules that, under the right conditions, will spontaneously self-assemble into ordered layers on a solid substrate. And this gives you a ton of flexibility to make medical devices, nanotechnology, basically anything you can dream of, because you can tune that molecule to have any specific group on the end of it that then change the functionality of that surface. So we're looking at those molecules for the sake of biomedical applications. So lots of folks have proposed that you can use surfaces functionalized in this way to attract a biomolecule, for example, or to operate as a glucose sensor for a diabetic patient. So there's a lot of ways that these molecules can be used to make medical devices across kind of development and discovery. And what we're doing as a PChem lab, as a physical chemistry lab, is we're trying to figure out under what circumstances are these molecules not as well organized as we'd like to think. So we know there are lots of factors such as environmental conditions, deposition procedure, and the treatment of these devices that might make those molecules not actually order up in the nice little way that we want, but have some defects and some disorganization. And we want to know what factors impact that disorganization, and then if that disorganization is present, does it impact or negate the properties as biosensors that we want? So we want to kind of tune that gulf there, which is understanding under what circumstances these surfaces might not be as organized as we think, and if and how that impacts using those surfaces as biomedical devices. And the I4 ROA has been essential in getting this done. This is my first year as a faculty member at St. Edward's, and I4 just gave us that last little burst of funding that helped us invest in some additional instrumentation. It helped us kind of build up a stock of supplies so that we can try a lot of these different synthetic procedures that we're doing for the first time. And so far in this first year, we've done a lot. We've really got this brand new spectroscopic module up and running. So we bought a commercial spectrometer and then outfitted it with all these extra optics so that we can do a very specific type of spectroscopy that lets you see just those monolayers of molecules on the surface. So we had to build up this whole apparatus in order to see the molecules that we want to work with. And we did all of that over the course of this past year using the funding from this ROA PDG. And that's going to have a huge impact for my professional development and my students' professional development, because we not only now have meaningful experimental results that are going to help catalyze sort of the submission of larger grant applications, but we also now have this experimental design experience that's going to be really beneficial for designing meaningful experiments moving forward. So even if in the future we're branching out and away from these biomedical devices, we've got this expertise that allows us to build experimental technology kind of from scratch in order to look at the molecules or the systems that we're interested in.